Calculate return on equity using the DuPont decomposition. The company reports net income of 120, sales of 1,200, total assets of 800, and total equity of 400. Step 1, compute net profit margin. That's net income divided by sales. 120 divided by 1,200 equals 0.10 or 10%. Step 2, compute asset turnover. That's sales divided by total assets. 1,200 divided by 800 equals 1.5. Step 3, compute the equity multiplier. That's total assets divided by total equity. 800 divided by 400 equals 2.0. Step 4, multiply them together. Net profit margin times asset turnover times equity multiplier. First multiply 0 or 10 times 1.5. That equals 0.15. Now take 0.15 times 2.0. That equals 0.30.
All right, let's calculate the weighted average cost of capital WACC. The formula is equity over total capital times the cost of equity plus debt over total capital times the cost of debt times 1 minus the tax rate. Here are the numbers. Equity equals 600. Debt equals 400. Cost of equity is 12%. Cost of debt is 6%. And the tax rate is 30%. Step 1. Calculate total capital equity plus debt. 600 plus 400 equals 1,000. That's our denominator. Step 2. Compute the equity weight. Equity divided by total capital. 600 divided by 1,000 equals 0.6. Step 3. Compute the debt weight. Debt divided by total capital. 400 divided by 1,000 equals for step 4. Apply the formula. Take equity weight 0.6 times cost of equity 0.12. That equals 0.072. Then take debt weight 0.4 times cost of debt 0.06. That gives 0.024. Multiply that by 1 minus the tax rate, which is 0.724 times 0.7 equals 0.0168. Finally, add the two parts together. 0.072 plus 0.0168 equals 0.0888. So the weighted average cost of capital is about 8.8%.
Let's calculate the expected return of a stock using the capital asset pricing model CAPM. The formula is expected return equals the risk-free rate plus beta times the market risk premium. The market risk premium is the expected market return minus the risk-free rate. Here are the numbers. Risk-free rate equals 3%. Expected market return equals 9%. Beta equals 1.2. Step 1, set up the formula. Expected return equals 0.03 plus 1.2 times open parentheses 0.09 minus 0.03 close parentheses. Step 2, work inside the parentheses. 0.09 minus 0.03 equals 0.06. That is the market risk premium.
Step 3, multiply by beta 1.2 times 0.06 equals 0.072. Step 4, add the risk-free rate 0.03 plus 0.072 equals 0.102. So return on this stock is about 10.2%.
Let's calculate the intrinsic value of a stock using the dividend discount model, also called the Gordon growth model. The formula is price today equals next year's divided by the required return minus the growth rate. Here are the numbers. The dividend next year. D1 is $2. The required return is 8%. The dividend growth rate is 3%. Step 1. Write out the formula. Price 0 equals $2 divided by 0.08 minus 0.03. Step 2. Calculate the denominator 0.08 minus 0.03 equals 0.05. Step 3, divide $2 divided by 0.05 equals $40. So the intrinsic value of the stock is $40.
Let's calculate free cash flow to the firm FCFF. The formula is FCFF equals cash flow from operations plus interest times 1 minus the tax rate minus capital expenditures. Here are the numbers. Cash flow from operations is 500, interest expense is 100, the tax rate is 30%, capital expenditures are 150. Step 1, write the formula. FCFF equals 500 plus 100 times open parentheses 1 minus 0.30 close parentheses minus 150. Step 2, work inside the parentheses. 1 minus 0.30 equals 0.70. Step 4, add this time to cash flow from operations. 500 plus 70 equals 570. Step 5, subtract capital expenditures. 570 minus 150 equals 420. So free cash flow to the firm equals 420.
equity, FCFE. The formula is FCFE equals cash flow from operations minus capital expenditures plus net borrowing. Here are the numbers. Cash flow from operations is 500. Capital expenditures are 150. Net borrowing is 50. Step 1, write the formula with the number. FCFE equals 500 minus 150 plus 50. Step 2, subtract capital expenditures. 500 minus 150 equals 350. Step 3, add net borrowing. 350 plus 50 equals 400. So free cash flow to equity equals 4.
Calculate net present value, NPV. The formula is NPV equals the sum of discounted future cash flows minus the initial investment. Each cash flow is divided by 1 plus the discount rate raised to the power of time. Here are the numbers. Initial investment is 1,000. The cash flows are 400 in year 1, 500 in year 2, and 600 in year 3. The discount rate is 10%. Step 1, write the formula with the numbers. NPV equals 400 over 1.10 plus 500 over 1.10 squared plus 600 over 1.10 cubed minus 1,000. Step 2, discount each cash flow. 400 divided by 1.10 equals 363.64. 500 divided by 1.21 equals 413.22. 600 divided by 1.331 equals 451.17. Step 3, add them up. 363.64 plus 4, 13.22 plus 4, 51.17 equals 1,227.99. Step 4, subtract the initial investment, 1,227.99 minus 1,000 equals 227.99. So the net present value is about 228.
Let's calculate the internal rate of return, IRR. The project costs 100 today and pays back 120 in 1 year. Step 1, write the equation. 0 equals 120 over 1 plus IRR minus 100. Step 2, move the 100 across 100 equals 120 over 1 plus IRR. Step 3, flip it around. 1 plus IRR equals 120 divided by 100, which equals 1.20. Step 4, subtract 1. IRR equals 0.20 or 20%. So the internal rate of return for this project is 20%.
HPR. The formula is price at the end minus price at the beginning plus dividends, all divided by the beginning price. Here are the numbers. The stock was bought at $50. After 1 year, the price is $55. The dividend received is $2. Step 1, write the formula with the numbers. HP odd equals 55 minus 50 plus 2 all over 50. Step 2, simplify the numerator. 55 minus 50 equals 5. 5 plus 2 equals 7. Step 3, divide by the beginning price. 7 divided by 50 equals 0.14. So the holding period return is 14%.
Let's calculate the geometric mean return. The formula is multiply 1 plus each return together. Then take the nth root and subtract 1. Here are the returns. Year 1 is 10%. Year 2 is 20%. Year 3 is negative 10%. Step 1, convert each return into a growth factor. 1 plus 0.10 equals 1.10. 1 plus 0.20 equals 1.20. 1 minus 0.10 equals 0.90. Step 2, multiply the factors together. 1.10 times 1.20 times 0.9. 0 equals 1.188. Step 3, take the cube root. Since we have 3 years, the cube root of 1.188 is about 1.059. Step 4, subtract 1. 1.059 minus 1 equals 0.059. So the geometric return is about 5.9%. Let's calculate the sample standard deviation of returns. The returns are 8%, 12%, and 10%. Step 1, calculate the mean return. Add them up, 8 plus 12 plus 10 equals 30. Divide by 3. Observations, 30 divided by 3 equals 10%. That's the average return. Step 2, subtract the mean from each return. 8 minus 10 equals negative 2. 12 minus 10 equals positive 2. 10 minus 10 equals 0. Step 3, square each deviation. Negative 2 squared equals 4. Positive 2 squared equals 4. 0 squared equals 0. Step 4, sum the squared deviation. 4 plus 0 equals 8. Step 5, divide by n minus 1. We have 3 observations, so n minus 1 equals 2. 8 divided by 2 equals 4. Step 6, take the square root. The square root of 4 equals 2%. So the sample standard deviation of returns is 2%.
Let's calculate the sample covariance between two stocks, X and Y. The returns are as follows. Period 1, X is 10%, Y is 12%. Period 2, X is 8%, Y is 7%. Period 3, X is 12%, Y is 15%. Step 1, calculate the average of each series for x. 10 plus 8 plus 12 equals 30. Divide by 3 and the mean of x is 10% for y. 12 plus 7 plus 15 equals 34. Divide by 3 and the mean of y is 11.33%. Step 2, subtract the mean from each observation. For x, 10 minus 10 equals 0. 8 minus 10 equals negative 2. 12 minus 10 equals positive 2 for you. 12 minus 11.33 equals 0.67. 7 minus 11.33 equals negative 4.33. 15 minus 11.33 equals positive 3.67.
3, multiply the deviations in each period. First period, 0 times 0.67 equals 0. Second period, -2 times -4.33, 8.66. Third period, 2 times 3.67 equals 7.34. Step 4, sum the product. 0 plus 8.66 plus 7.34 equals 16. Step 5, divide by n-1. We have 3 observations, so n-1 equals 216. Divided by 2 equals 8. So the sample covariance between x and y is 8. Let's calculate the correlation coefficient between 2 stocks, x and y. The formula is correlation equals covariance divided by the product of the standard deviations of x and y. Here are the numbers. The covariance between x and y is 8. The standard deviation of x is 4. The standard deviation of y is 5. Step 1, write the formula with the numbers. Correlation equals 8 divided by 4 times 5. Step 2, multiply the denominator. 4 times 5 equals 20. Step 3, divide 8 divided by 20 equals 0.40. So the correlation coefficient between x and y is 0.40. That means the 2 stocks have a moderately positive relationship. Divided by 20 equals 0.40. So the correlation coefficient between x and y is 0.40.
Let's calculate beta, the measure of systematic risk. The formula is beta equals the covariance of the stock's return with the market return divided by the variance of the market return. Here are the numbers. The covariance between the stock and the market is 18. The variance of the market is 36. Step 1, write the formula with the numbers. Beta equals 18 divided by 36. Step 2, divide 18 divided by 36 equals 0.50. So the stock's beta is 0.5. That means this stock has half the risk of the market and will move less than the market overall. Step 2, divide 18 divided by 36 equals 0.50. So the stock's beta high. Step 2, divide 18 divided by 36 equals 0.50. So the stock's beta is 0.5. That means this stock has half the risk of the market and will move less than the market overall. Let's calculate the expected return of a portfolio. The formula is portfolio. Expected return equals the sum of each asset's weight times its expected return. Here are the numbers. Stock A has a weight of 40% with an expected return of 8%. Stock B has a weight of 60% with an expected return of 12%.
Step 1, write the formula with the numbers. Portfolio return equals 0.40 times 0.08 plus 0.60 times 0.12. Step 2, multiply each term. 0.40 times 0.08 equals 0.032. 0.60 times 0.12 equals 0.072. Step 3, add them together. 0.032 plus 0.072 equals 0.104. So the expected return of the portfolio is 10.4%.
Let's calculate the variance of a two-asset portfolio. The formula is formula variance equals weight of a square times variance of A plus weight of B squared times variance of B plus 2 times weight of B times weight of B times the covariance of A and B. Here are the numbers. Stock A has a weight of 0.5 and a standard deviation of 10%. Stock B has a weight of 0.5 and a standard deviation of 20%. The covariance between A and B is 0.015. Step 1, square the standard deviations. 10% squared is 0.01. 20% squared is 0.04. Step 2, compute each variance term. Weight of a squared is 0.25. Multiply by 0.01 and you get 0.0025. Weight of B squared is also 0.25. Multiply by 0.04 and you get 0.0100. Step 3, compute the covariance term. 2 times 0.5 times 0.5 equals 0.5. A portfolio standard deviation of about 14.14%.
Let's calculate the Sharpe Ratio. The formula is Sharpe equals the portfolio's expected return minus the risk-free rate divided by the portfolio standard deviation. Here are the numbers. The portfolio's expected return is 10%. The risk-free rate is 2%, and the portfolio standard deviation is 12%. Step 1. Write the formula with the numbers. Sharpe equals open parentheses 0.10 minus 0.02 close parentheses divided by 0.12. Step 2. Subtract the numerator. 0.10 minus 0.02 equals 0.08. Step 3. Divide by the denominator. 0.08 divided by 0.12 equals 0.667. So the Sharpe ratio is approximately 0.67. This means the portfolio is earning about 0.67 units of excess return for each unit of risk.
Let's calculate the modified duration of a bond. The formula is modified duration equals Macaulay duration divided by 1 plus yield over me, where M is the number of coupon periods per year. Here are the numbers. The Macaulay duration is 5 years. The yield is 6%. Payments are annual, so M equals 1. Step 1. Write the formula with the numbers. Modified duration equals 5 divided by 1 plus 0.06 over 1. Step 2. Simplify the denominator. 0.06 over 1 equals 0.06. 1 plus 0.06 equals 1.06. Step 3. Divide 5 divided by 1.06 equals 4.717. So the modified duration is about 4.72 years. This means the bond's price will change about 4.72% for every 1% change in yield in the opposite direction.
Let's calculate the convexity of a simple 2-year bond. The formula is convexity equals 1 over price times the sum of each cash flow multiplied by t times t plus 1 divided by 1 plus yield raised to the power of t plus 2. Here are the numbers. The bond price is 1,000. The yield is 5%. The cash flows are 100 at year 1 and 1,100 at year 2. Step 1, calculate the year 1 term. 100 times 1 times 2 equals 200. Divide that by 1.05 raised to the 3rd power. 1.05 cubed equals 1.1576. 200 divided by 1.1576 equals about 172.8. Step 2, calculate the year 2 term. 1,100 times 2 times 3 equals 6,600. Divide that by 1.05 raised to the 4th power. 1.05 to the 4th equals 1.215. 6,600 divided by 1.215 equals about 5,430.2. Step 3, add the terms together. 172.8 plus 5,430.2 equals 5,603. Step 4, divide by the bond price. 5,603 divided by 1,000 equals 5.603. So the convexity of this bond is about 5.6.
Let's calculate the yield to maturity, or YTM, on a simple 2-year bond. The bond price is $950. The face value is 1,000. The annual coupon is $60, and the bond matures in 2 years. The formula is price equals the sum of cash flows divided by 1 plus YTM to the power of time. Step 1, write out the cash flows. Year 1 pays $60. Year 2 pays $1,060, which is the final coupon plus principal. Step 2, set up the YTM equation. 950 equals 60 over 1 plus YTM plus 1,060 over 1 plus YTM squared. Step 3, use trial and error. If YTM is 8%, 60 over 1.08 equals 55.56. 1,060 over 1.08 squared equals 908.07. Add them together and you get 963.63. That's high which means the guess is too low. Step 4, try 9%. 60 over 1.09 equals 55.05. 1060 over 1.09 squared equals 892.59. Add them together and you get 947.64. That's almost exactly 950. So the yield to maturity on this bond is about 9%.
Let's calculate the value of a European put option using put call parity. The formula is call price plus the present value of the strike equals the put price plus the stock price. Here are the numbers. The call option is worth $6. The present value of the strike is $45. The stock price is $51. Step 1. Set up the equation. 6 plus 45 equals P plus 51. Step 2. Add the left-hand side. 6 plus 45 equals 51. So the equation is 51 equals P plus 51. Step 3. Solve for P. Subtract 51 from both sides. P equals 0. Of the put option in this example is $0. Step 1. Set up the equation. 6 plus 45 equals P plus 51. Step 2. Add the left-hand side. 6 plus 45 equals 51. So the equation is 51 equals P plus 51. Step 3. Solve for P. Subtract 51 from both sides. P equals 0. Let's calculate the futures price using the cost of carry formula. The formula is futures price equals the spot price times 1 plus the risk-free rate raised to the power of time minus any costs of carry, dividends, or yield. Here are the numbers. The spot price is 100. The risk-free rate is 5%. The time to maturity
up the formula with the numbers. Futures price equals 100 times 1 plus 0.05 to the power of 1. Step 2, simplify inside the parentheses. 1 plus 0.05 equals 1.05. Step 3, multiply. 100 times 1.05 equals 105. So the future's price is 105.
Let's calculate the price to earnings ratio or P ratio. The formula is price to earnings equals the price per share divided by earnings per share. Here are the numbers. The stock price is $50 and the earnings per share are $5. Step 1, set up the formula with the numbers P over E equals 50 divided by 5. Step 2, divide 50 divided by 5 equals 10. So the PE ratio for this company is 10. That means investors are paying $10 for every $1 of
Let's calculate the interest coverage ratio. The formula is interest coverage equals earnings before interest and taxes divided by interest expense. Here are the numbers. EBIT is 300, interest expense is 75. Step 1, write the formula with the numbers. Interest coverage equals 300 divided by 75. Step 2. Divide 300 divided by 75 equals 4. So the interest coverage ratio is 4. That means the company earns 4 times as much as it needs to cover its interest expense. Coverage ratio is 4. That means the company earns 4 times as much as it needs to cover its interest expense.